guys, this is Victor and we are going to be showing today an exciting lab about EIGRP American in Florida, and hopefully you're going to have some fun with this kind of lab right now. Guys, I hope that you have an excellent day. I enjoy this lab as well. Have an excellent day. Hello guys, this is Victor and we're going to be having today a very exciting lab. It was based on Cisco Network Academy that you can find on the web, and it's basically the configuration of the advanced EIGRP for IPV4 features. Before we start everything, explaining how we are going to be working, there are a couple stuff that we're going to be explaining. First, we have three options to do this kind of lab. We could do that in packet traces, that is a simulation. We could do that in GNS3, that is an emulator, and we can do that on real equipment. But in real equipment, you wouldn't see any graph, and the concept of everything, how we organize everything on each one of the interface, you need to have some physical explanation how everything is coming. So I can start jumping on that, but I want you that you see, and we're gonna try to do this exercise as fast and easy for you as possible. One more thing to make this exercise as fast as possible, so you understand, we're gonna do a lot of copy and paste. I don't want that this is gonna be a typing contest, because this exercise I don't want that it lasts 2 or 3 hours. So it's gonna be a lot of copy and paste. So it's gonna be way easier and smoother for you. The information is gonna be over here, the links for this lab, the original Cisco lab, and our lab that we make, as you could see over here. This is the lab that we have, and this is the other lab of Cisco Network Academy. Basically over here we're gonna see the gigabyte 0/0. I don't want to start jumping on fiber optic gigabyte Ethernet right now. I want that you make sure that you understand that. So I'm assuming that you buy your old equipment from eBay or Amazon, then and in a work environment you're gonna see the fast Ethernet, the gigabyte Ethernet with fiber optic cables, but not when you start playing with this kind of device. So instead of G 0/0, we're gonna be using fast Ethernet 0/0 in case that you want to connect that personally. Over here on the other interface, S 0/0/0. I don't want to jump in that kind of stuff because it's way too long, so it's gonna be only 20 S 0/0. One more thing, I want that you pay attention to the bandwidth that we're gonna be selecting over here, and over here for this connection that we're gonna be applying in the future. I want that you see the loopbacks over here in each one of them, and I want that you see the DCE. The DCE is where you're gonna be applying the clock rate. For example, on the connection S0/0, the clock rate is gonna be applying over here because you see the DCE. The same thing in this router on the connection interface S0/0, and over here in the interface S0/1. So this is the values that they have over here. This is the values that we are going to be applying over here on real life. Nice and smooth. And this is going to be our GNS3 lab that I already configured, because I want to make sure that everything is going to be coming a little bit easier for you guys. And I want to configure that first in hand. You have no value and you only have made the connection. So I want to save your time. One more thing. You see over here, it was supposed to be gigabyte 0/0, fast Ethernet 0/0. It's gonna, the subnet mask is gonna be 255.255.255.0, and the next one on the serial interface is gonna be 252 at the end, 255.255.252, and the same thing is gonna be applying fast Ethernet. Is gonna be your LAN interface, the one that is connected to the computer. Let me show you, like over here, guys. And you're going to be asking why? What is the difference? Well, because when we are talking about a CIDR mask of 30, it corresponds to 255, 255, 255, that 252. Guys, I want that you try to see how the graphic works. And because it's 252, it works with a CIDR mask of 30. Got it? No. I'm assuming that you're coming with some background with CCNA, so I don't want to jump in that kind of stuff. another one that you waste a lot of time doing that kind of stuff. Objective, guys. When we are talking about objective, let's see what we are going to try to achieve on this exercise. Number one, build a network, configure the basic device settings. The thing that we are going to be doing in a couple seconds. That is basically assigning the values on each one of the interface on the GNS tree. Configure the EIGRP and verifying connectivity. Basically, we're going to be applying the network protocol EIGRP and ping after that. Configure summarization for EIGRP. There is a explanation on how to make everything very smooth for you guys. Configure and propagate the default standard route. Probably something that they're going to be asked what that you get over there on your personal lab, on your personal work environment where you're going to be working. Fine tuning the EIGRP that we are going to be talking about band utilization. The hello intervals and hold timer. What are they? How we're going to use it and why are they important for? And the configuration of EIGRP authentication. Something very important, guys, because we want to make your network secure, that nobody can get in and you wouldn't have any issues in the future. You can have some peace of mind because you have authentication on each one of the routers. Excellent. Now we're going to start jumping on part one that you see over here, build a network, configure the device setting. But one more thing, I already set up graphically how the topology was going to be working. And there's a couple stuff over here. DNS lookup, topology, BTI password, security password. I don't want to be jumping on that because you already saw that kind of stuff on CCNA. And I don't want this exercise to last 10 hours. So we're going to make sure that everything is going to be working as smooth as possible. One more thing that is important before starting this exercise is that it was required that you don't configure the loopback interface at that time. Ready? Ready to jump? We're going to have some good time over here. I want you to be ready with that. So, on router 1, we're going to start doing the configuration right away. We're going to do a copy and paste with the values that you saw on the addressing table. This one over here. And we're going to be applying everything that you could see. Oh, the clock rate is very important that you realize that we put it down. The explanation that I tell you before. And let's start jumping on this right away. So console, we're going to do a little bit of copy and paste for these guys. Everything is set up, everything is moved, and everything is coming up, guys. So far, this exercise is doing good. So let's start doing on router 2. Remember one more time that I want you that you do that in the future, step by step, each one of them, and you will know how all the numbers over here and all the values that we are applying, that you do that on your own. So on R2, everything came nice and smooth. Now we're gonna do the same thing on R3. All the links are up. Excellent, guys. Link from the 0/0/1 and 0/0 serial 0/0 and serial 0/1. Okay. Configure EIGRP and verify connectivity. So we're going to do the configuration of the protocol. On R1, we're going to be using autonomous system of 1. And we're going to be applying the protocol EIGRP on the network. Copy. We have a typo over here. Excellent. So on the part B, we already applied the stuff over there on router 1. On the part B, for the LAN interface, that means this part over here where the computer, where the host is located at, we don't want basically that it sends the hello packets. That interface F0.0. Why? Because basically we don't want to form any adjacencies over there with the LAN over there on R1. So it's not going to be forming any adjacencies in the neighborhood over there, and it won't form any updates with the very specifically F0.0. On R1, or still on router 1, configure the bandwidth of S0/0 with this by 1024 kilobytes per second and the bandwidth of S0/1 64 kilobytes per second. Smooth and easy. On R2, we're gonna do almost the same thing that we already done. We store the hello packets through the passive interface command, and we're gonna configure the value 1024 kilobytes per second. R2. We're configuring as well the EIGRP autonomous system number 1 and the network as well. But look what happens right now. Now that we activated it, it found a neighbor, an adjacency with R1. R1 didn't have this before because we haven't configured R2 or R3 before, but now it does because it found a new neighbor. That's excellent. That's because it's making adjacencies. Now on R3, we're going to do something similar. But on the 0/0/0, we're going to assign the 64 kilobytes per second. And you could see that it formed adjacencies with the 0/0/0 and 0/0/1. That's interesting. Now this one, because the three of them, router 3, we just configure router 3, and it could read a neighbor on R2 with the hello packets and with R1 as well. So we are doing excellent right now. We're going to test the connectivity. When we are talking about testing the connectivity, we are going to be checking on R1. I don't want to do in each one of the interface, but I want you to see what we are talking about on R3. We're going to try to ping to see that we got some connectivity. No. Excellent. And the other one, the other value that we see over here, let's see if it can find it. %. Guys, this exercise is coming so far very, very good and easier for you. Part 3, configuration summarization of EIGRP. issue the show IP protocol command on R1. What is the default status of the automatic summarization in EIGRP? To do that, we're gonna establish a show IP protocol command. So give me 2 seconds, guys. So the answer for this, you're gonna find this over here. Automatic network summarization is in effect. In other words, summarization is enabled right now. One more thing that I want to tell you, from the iOS 15 of Cisco, automatic summarization is not in effect by default. In this case, on GNS3, this version that I have, it doesn't have the iOS 15 when the default, there was a default automatic summarization. So you're working with the latest Cisco equipment, the latest one, you won't find this kind of stuff. But it's very good that you know what you're trying to achieve so far right now. So let's start checking the next part of the exercise. Configure the loopback address of R1. Guys, this loopback address is on the addressing table, the one that you saw over here. You see? Do you remember that it was required that we do that in this part of the exercise? Do not configure loopback interface at this time. And the values are over here. You see, 1, 5, 9, and 13. And we're going to be using this part over here. The loopbacks are all up. Over here, add the appropriate network statement to EIGRP process on router 1. Record the commands used in the space below. Okay, we could finally apply all the values over here. On R2, issue the show IP route EIGRP. Okay, we can do that, guys. Let me see. Copy on R2. So the question is, how are the loopbacks address represented? Remember that the loopback address is 192.168.11. And how they are represented over here? Over here, they have an insider mask of 24. That means that they are summarized. So what are we gonna do now? On R1, issue the auto summary command inside the EIGRP process. Okay, let's do that. How does the routing table on R2 change? Let's check it out. This is R2. Now let's start jumping on the step 2. Configure manual summarization for EIGRP. Configure the loopback address on R3. Let's get the R3. Enable conft and the values we're gonna copy and paste over here. Boom. Nice and easy. Got it, guys? Well, now the next step is, after we configure the R3, add the appropriate network statement to the EIGRP process on the R3. So let's start working on that right now. These are the network statement. Look at the statement 192.168.333.04812. If one number less than the one that you see over here on the loopback. Do you see it, guys? Hopefully you do. So let's start posting that stuff on R3. Network statement. You got it. On R2, it should show IP route EIGRP command. Okay. How are the loopback networks from R3 representing the output? Let's start first on R2. How the loopback network are represented. So let's check it out. Over here, you see the summarization is enabled by default in this version of EIGRP. In the next version, as I mentioned before, iOS 15 of Cisco, or the latest routers, real equipment, that's what I mean, you will find this kind of issue because they don't have automatic summarization on these devices. Let me tell you, talking about summarization, let me show you something really quick over here. So guys, we already had the appropriate network statement on IGR process on R3, and the output you saw it. On R2, show the IP route EIGRP command. How are the loopback network from R3 represented? So I think that I show you over here in this part over here. So there is something interesting over here that I want you to show on the summarization. Guys, before everything starts, let me try to summarize a couple stuff so you're gonna see something that I want you to explain. How I summarize. We were talking about the network 192.168.33.0 or whatever. And the loopback address that you could find over here in this statement, 0, 4, 8, and 12. we're gonna do a little bit of summarization over here, and I don't want to jump a little bit further so you can understand this. 192.168.133.0. Over here, everything is smooth. So we have 1, 2, 3, 4 octets. This is a full octet over here and over here, and this is a class full. So over here, remember when you start learning about CCNA, we're gonna start getting this number from 4. 4 is gonna be the second number over here, 4, the full number. 8 is gonna be the full number over here. But 12 is not. You don't have a full number because 1 is gonna be double everything. 1, 2, 4, 8, 16, whatever. So for 8 is gonna be 8 plus 4, 12. So we're gonna be jumping from the 4 octets. 1 is full, this one is full, this one is full, but this one is not. So we're gonna be counting till this line over here. 1, 2, 3, 4, 25, 26, 27, 28. And that is gonna take us, guys, to our table that we put over here. 25, 26, 27, and 28. And we're going to be talking about 28, guys. Remember that the other one over here, they are not full. This part over here. So the one that is full is 28, 25, 26, 27, 28, and we're going to be counting on the 240. So we are talking about the subnet mask of 28. And subnet mask of 28, we are talking about the number 240. I'm going to put this stuff over here. I want you to understand this as well. So the summarization of everything, of all these numbers, is going to be /28. And subnet mask is going to be 25, 25, 25, 240. Please pay attention to what I'm doing because I want that you will be able to summarize as well in case that you forget. And it's the easiest way that I use to do my personal summarization. Got it, guys? Okay, let's jump in this water. So in the previous example, determine the summary EIGRP route for the loopback address and write the summary route in the space below. I'll show you how I was doing this, and I hopefully you understood what I was talking about. I know that everybody have a different way to do this. This is my personal way to do that. Exercise E. For the serial interface of R3, issue the IP summary address EIGRP1 network address subnet mask. Command to manually summarize the network. Okay, we can do that. R3. So over here, you saw some changes. There is some summarization configured, as you could see on the table. So on this last part over here, how does the running table on R2 change? We're gonna double check that right now. So in this value over here, 192.168.33.0 /28 is no longer /24, it's /28 because we apply Summarization, guys. Remember that the value that we put, because we did the exercise before in Excel on how we summarize, everything now is summarized as you could see. Excellent. This exercise is working for us. Now, let's continue with the next part of this exercise. Configure and propagate a default static route. On part 4, you will configure the default static route on R2 and propagate the routes to all other routers. Configure the loopback address on R2. Okay, let's do that. So, to configure the loopback address, remember that we see over here there is only one loopback address, one that you could see over here. It doesn't have all these loopbacks. On R2 we only have one loopback address 1. Loopback 1 on R2 is up. Now we're going to configure the default static route. Done deal. Use the redistribute static command with the EIGRP process to propagate the default static route to other participating routers. Ready to roll on R2. Next command. Use the show IPV4 protocol command on R2 to verify the static route is being distributed. Okay, let's double check. We're gonna see over here this part that we were looking for, redistribution static EIGRP1. So we could verify that the redistribution was static, and so far this exercise is coming nice and smooth for us, guys. Excellent. So for the next part of the exercise, on R1, issue the show IP route EIGRP, well, this command to view the statement to specific to the default route. How the static default route representing the output? What is the administrative distance for the propagate route? Let me adjust over here so you'll see it. So when we issue the command show IP route, EIGRP, whatever includes 0.0.0.0, it's showing me this. The administrative distance is 170. That is the default administrative distance of external EIGRP. So this is a very important information, guys. because you don't see that very often. This is going to be the keyword of everything, this part that I am pointing out. Default external administrative definition 170, that is correspond to the EIGRP. In other words, it's the external learn EIGRP route. Now that we did that, we are going to configure the serial link between R1 and R3 to allow only 40% of the bandwidth. Remember to check the graphic. So on R1, we're going to put this value. On R2, we're going to put the other value over here. Excellent. Now, let's go to the step number 2. Configure the hello interval and hold timer for EIGRP. Show IP EIGRP interface details. So we're gonna have to use this stuff over here, this command. Over here, you're gonna see the hello interval of 5. By default, Cisco assign a hello interval of 5, and we can also, the hold timer is not coming by default with this command over here in DNS3, but we know that the hold timer is 15. So hello interval is 5 seconds and hold timer is 15. The default value for hello time. What is the default value for hold time? I guess that we just explained that situation. Configure as serial 0/0 and serial/1 interface on R1 to use a hello interval of 60 seconds and a hold time of 180 seconds in that specific router. So we're gonna do that right now, guys. It's gonna be only on R1. We see the hello interval over there. Excellent. On each one of the loopback as well. So we apply then this information, configure the serial interface on R2 and R3 to use a hello interval of 60 seconds and a hold time of 180 seconds. We're going to configure the serial interface of R2 and R3 using the same values, guys. R2. And now we're going to do the same thing with R3. Great. Use the show IP EIGRP interface detail command to verify the configuration. So let's start jumping on the next part of the exercise. Configuration of EIGRP authentication. In part 6, you will create authentication key from all routers and configure routers interface use MD5. So let's do that right away. On R1, use the keychain name command in global configuration mode to create a keychain, the label EIGRP-keys. So we're going to try to do this. Copy. On R1. So on R1, and now let's double check on R2. Boom. And on R3, the same stuff. Now, issue the show key change command. We see some values over here. Key 1, text, Cisco. So everything so far is running nice and smooth. We're going to be checking on the other routers as well. Key 1, test Cisco, and we don't need to do that on router number 3 because we know that it's going to have the same results. So configure EIGRP link authentication. Apply the following commands to active EIGRP authentication to the serial interface on R1. So let's start jumping on that right now, guys. Apply that on R1. Boom. And you're gonna see successfully you could see that we apply and we activate that on router 1 and on router 1 only, but we need to activate everything on router 2 and router 3. So let's double check and let's do that right now. And let's do this right now on R3, but before doing that, you see that he discovered a new adjacency right now from R1, not from R3, because we haven't configured R3 yet. So let's do that right now. Let's jump into R3 and let's see if there is some authentication as well. Now you see that it's popping up, and it's popping up. I can see that from over here as well. The situation is changing on the back. So from R3, there is authentication coming from R2 and R1. So this exercise is successful, guys. Excellent. I am so happy. So let's go over here, copy on R2. We can see the hello intervals are 60 seconds. Whole timer doesn't show over here in this version of DNS3. But at least we got some information right now on real equipment. You could see that as well. So this exercise is well done. Well, guys, now we arrive at the last part of this exercise. That's excellent. So far, everything is smooth. So we're going to be talking about reflection. So the last part over here on reflection is what are the benefits of summarizing routes? Well, summarizing can be used for certain different stuff. The biggest benefit that I see so far is that it limits the number of route advertisement, guys, and as well of the size of the routing table. Remember that is in contrast to flat routing, where every route table contains a unique entry for each one of the routes. So the second part is when setting EIGRP timer, what is important to make the whole time value equal to or greater than the hello intervals. Well, guys, if the whole time value is less than the hello interval, the network adjacency goes down. So it's very important that you pay attention that the value for the whole time is gonna be equal to 15 seconds, and the value for hello intervals is gonna be 5 seconds. Remember that we saw that on the previous exercise. And the last part of everything, why it's important to configure authentication for EIGRP. Guys, you want to have some peace of mind, you want to sleep at night, you don't want any hackers, nobody stealing your information, nobody trying to redirect the network, the information, the financial data, the personal data of everybody, and integrity of your company. So you need security to be safe, to have some peace of mind. This is why this part is so important. Authentication is the key for the peace of mind of your heart and your network and your job as well, guys. So, guys, this exercise was great. This exercise was excellent. I had so much fun. And now you're an expert in EIGRP for IPV4 in this advanced exercise. Believe me that you did pretty good if you went through all the part of this exercise, and I hope that you have a great time, and thank you very much for watching. Guys, have an excellent day, and thank you very much one more time. Keep in touch and keep watching, so you're gonna be learning a little bit more.